Let's go ahead and graph some examples here. Let's take a look at two graphs here and see which one is function and which one is not a function. If this is y-axis and if this is x-axis. All right. Now, the first graph that I want to show here is a graph of parabola. It looks like that opens upward. And the next graph that I want to show you is the graph of parabola that opens to the right like that. We're going to talk about the graph of parabola later, but just looking at these two shapes. In order to see if which one of these is function, there's a test is known as, anybody know the name of the test? If you know the name of the test to check if a graph is function, please put a check mark next to your name. If you know the test, put a check mark next to your name. If you don't know it, put the X next to your name. That's okay. Okay, that is actually the answer to number 4. Number 4 in your take-home test. This is a graph represent a function if it pass a blank line test. Anybody know that? Yeah, vertical. Very good. Heidi says vertical. That's called vertical test. Now, vertical test means you draw a vertical line through the graph. Okay, let's draw a vertical line through the graph. And if you do that, if that vertical line passes your graph exactly at one point and one point only, then the graph that you're looking at is a function. See, this vertical line would passes through this figure only at one point. So if I move this vertical line to the right or left, let's say I would move it to the right. I move this to the right, I move it right here. Still gonna intercept my graph at one point only. That's called vertical line. So any vertical line I draw through this graph only gonna pass this line at one point and one point only. However, in the second example, if I did the same thing, if I draw a vertical line here, as you see, the line gonna pass through 2 points in this case. When that happens, we would say that is not function. So for right now, we say this is a function. The second example is not function. Can I say check mark next to your name if you can follow this, if you can remember this concept for the exam? So if I give you a graph and I ask you whether it's a function or not, that's all you do, just draw a vertical line through it and see if that line passes your graph at one point only. If it does, then you say, yes, that's a function. If it doesn't, like in the second example, you say it's not a function. Okay. The reason the second one is not a function is because when I draw a vertical line through it, my vertical line passes through the graph at more than 1 point, not only 1 point. Okay, this is a point right here. This is a point right there. As a matter of fact, let's go ahead and locate this point. So let's, if this is 1, and this is 1, and this is -1. The second example, the vertical line passes through the graph at this point here, which is 1, 1. Also, it passes the graph at this point here, which is 1 and -1, right? Whereas in this one, if this is 1, and this is minus 1. Your vertical line only passes through the graph at 1 point and 1 point only, which is 1, 1. Okay? And this the same line passes through the graph at 1 point and 1 point only. Okay, can I see a check mark next to your everyone's name then, if you understand this concept? Renee. Okay, Erica, are you okay so far? Daisy. All right, good. So now let's take a look at this closely. What happens when the line, the vertical line, passes through a graph in more than 1 point? Let's list those points. Like here, we have 1 point here. And here we have 1 point here. So if these were the points that represent our graph, at least a couple of them, how can you say if this is not a function just by looking at those 2 points? What are these points have in common? What point they have in common? Anybody? They're sharing what? Are they sharing x-axis or they're sharing y-axis? 1, exactly. They're sharing this 1, and that's the problem right there. So if the bunch of points that they're giving you, and they're asking if these points represent a function or not, without graphing those, if you can find the same point that shares for the x-axis, then you can say right away it's not a function. Why? Because those 2 points will be right on top of each other. Why? It's not a function because if I draw a vertical line through it, then it's not going to pass the vertical test. The vertical test was if I draw a vertical line through a graph, you should only intercept that graph at 1 point and 1 point only. So if you can find a couple of points right on top of each other on the graph, that's not a function. Whereas the other one, the points that I have is -1. That is, the first point is -1 and 1. And the second point is 1 and 1. As you see, they are not sharing the same number for the x. They're sharing a number for y, which is okay, which would be 2 different points, and that doesn't violate the vertical test. Well, can I see a check mark next to your name if you can understand this concept? Whether if I give you a bunch of points, ask you if they represent a function or not, or if I give you the graph, you should be able to determine whether it's a function or not. Okay, if you can follow up to this point, then I can move on to the next step. Okay, the question is from Heidi on the test, will I give you a bunch of points to see if it's a function or not, or I give you the graph? I can do both now, right? Because you know how to handle both. On the test, if somebody come and graph something for you here and ask you, Heidi, can you tell me whether this is a function? What would be your answer, Heidi? Yes or no? Is this a function? No, not function. Because it just doesn't follow the vertical test. If I draw a vertical line through this graph, it's going to intercept this graph more than 1 point, right there. Those 2 points would share the same x, which is right here. Can I see a check mark next to everyone's name, if you understand that part? So circle is not a function, not a function. But if I ask you whether, Daisy, you're okay with that? Daisy doesn't say check mark next to your name. Okay, we wait for Daisy. But if I say, how about the straight line? if I have y and x here, and I come up with just straight line like this. Is this a function? Okay. Is this a function? Renee says a function because it does pass the vertical test. Yes. Function. This is a function. So if I have a graph in front of me, it's very simple. I can go ahead and draw a line through it, and then I can see the function. Daisy, are you following us? I don't see any response from you. Okay, so if I draw a vertical line, for this, okay, if I draw a vertical line through this, see that vertical line passes through this only at one point. Only. Does that make sense? So yes, the straight line is a function. Can I say all straight lines are function then? No, Renee say no. Why? Can I say all vertical lines are all straight lines are function? Okay. So what we say yes, some of you no, and Renee says because it has to pass one point only. What about parallel? You're getting close to this answer. Well, Daisy, I think you're getting close to the answer. Anybody can tell me what line is not a function if it's a straight line? There's only one line, one straight line, that is not going to be a function, and that line is what? Not horizontal, because horizontal line is a function. Horizontal line indeed is a function. Okay, if I have an x and y axis here, and if I have a horizontal line, that's a function. This is a function. Well, you're getting very close. Not perpendicular means if two lines are making an angle, so that's not a horizontal is a function. Then we established that. So vertical line is not a function, right? Because if I draw a vertical line through vertical line, it's going to intercept that line in infinite points. That violate the definition of function. Everybody follow that? So all straight lines are function. So if I